Hello and welcome back to the 5.1 notes. This is part 2 over antiderivatives. So part 1 was a really important video as far as notation and what it is that we're doing. But I want to go through some of the antiderivative rules that we have. So I'm going to zoom in real quick. And so we have a few antiderivative rules that I want to go over and make sure that we understand. The first one, one of the more important ones is the constant multiple rule. So the constant multiple rule. And that's the rule that if you were to take the antiderivative of some number, some constant k, times a function f of x dx, then we can actually pull that constant out front and multiply it by the integral, okay? And so this is a rule that may not make sense to you right now, but later on, it'll kind of save your life to do it this way. So, but if I were to take some constant k and multiply it by the integral, then I'm just going to take k and multiply it by the antiderivative that we get. Okay, plus c. Okay, so that's the first one I wanted to talk about. The next one is the power rule. Okay, and the power rule means that if I take the integral of, say, some function, say x to the n dx, then that means that I'm going to increase my exponent by 1 and then divide by my new exponent, n plus 1, and then add c. Okay, so that's our rule that we have for the power rule. We also have, I'm going to zoom in here and do the exponential rule. Okay, and the exponential rule means that if we take the antiderivative or the integral of e to the x dx, then that's just going to give us e to the x plus c. Okay. I do want to talk about the trig rules for antiderivatives. So I'm going to come here and I'm going to write the trig rules. Okay. And so the trig rules that we have is that if we were to take the antiderivative of, say cosine of x dx, then that's going to give us sine of x plus c. Okay? If I took the antiderivative of, say, sine of x dx, then this is going to give me negative cosine of x plus c. So, and you have to think about it, guys, as if I took the derivative of just cosine, it would give me negative sine. But since I'm taking the derivative of negative cosine, it would give me positive sine. So the integral of sine of x is negative cosine. Okay. The other ones that we know, let's just go ahead and come in here and say that the antiderivative of, say, secant squared of x dx, the antiderivative of that is just tangent of x plus c. Okay. The other one that we know is the antiderivative of cosecant squared of x dx is equal to negative cotangent of x plus c. Okay, if we took the antiderivative of secant x times tangent x dx, then that's just going to give us secant of x plus c. And then if we took the antiderivative of cosecant of x times cotangent of x dx, and that's going to give us negative cosecant of x plus c. Okay, so you can always check this to see if you've done it right by taking the derivative. And I do have one more that I want to talk about, and that's the natural log rule. And this is something that is kind of confusing to some. And so I do want to talk about this one. And this is the natural log rule. Okay. And so if I were to take the integral of 1 over x dx, this is actually going to give me the natural log of the absolute value of x plus c, okay? Now, the main thing that you guys will kind of struggle with is the reason why do we have the absolute value of x here, okay? So if we think about this, if I were to graph, okay, so let's look at f of x equals 1 over x. The graph of that looks like this, okay, where you've got this rational function where the domain of that function goes from negative infinity to 0, unioned with from 0 to positive infinity, okay? So if we were to think of this, if you took the integral of 1 over x dx and you just got the natural log of x plus c, the problem is that you have a domain here. The domain of this function only goes from 0 to positive infinity, okay? So, but what you have to see here is that we need to include negative numbers, okay? And so in order to include the negative numbers that are a part of this domain, a part of this graph, we have to add in that we have the absolute value, okay? So this is big, okay? This is a big one. And we're going to see this quite a bit. So I just wanted to clarify that real quick. Hopefully that makes sense. If you got other questions, let's ask those in school. But let's go ahead. These are all the rules that we have currently. It doesn't seem like a lot of rules. When we had derivatives, we learned all sorts of rules. This is just the basic stuff, guys. We still have a lot to do and a lot to talk about. However, we'll be able to do the majority of our derivatives just by knowing these rules here, okay? So let's go ahead and take a look at number 30, okay? And so what we have is, we want to find the general antiderivative or indefinite integral, okay? And we can check our answers by taking the derivative. So what I want to notice here is that I want to find, let's just think about notation here for a second, okay? Here's what I've got. Let's let say f of x equal 1 minus x squared minus 3x to the fifth, okay? We want to find the antiderivative of that. We want to find big F of x, okay? And so, what I want to do is ask the question, okay, the derivative of what gives me this, okay? And that's what I'm going to do to find f of x. So let's go ahead. I'm going to rewrite this and say the integral of 1 minus x squared minus 3x to the fifth dx, okay, is equal to the following, okay? And if I were to take the antiderivative, or if I were to say, okay, the derivative of what gives me 1, then that would just be x, okay? If I took the derivative of x, it would just give me 1, okay? Now I need to do the power rule. And so I'm going to do this. I'm going to do, if I were to take the antiderivative of negative x squared, I'm going to put my negative sign there, and I'm going to say that this is just going to be x to the third power. I'm going to increase my exponent by 1, and then divide by my new exponent, okay? And then over here, minus, now I've got the 3, that's a constant multiple, I'm going to keep that there. So I've got minus 3, we had the x to the fifth power here, so I'm going to increase that by 1, and then I'm going to divide by my new exponent, which is 6, okay? And then I'm going to get, and then I have the plus c. So we can actually simplify this out and say that we get x minus x cubed over 3 minus x to the 6th over 2, and then plus c, okay? And that's really our big F of x. That's our antiderivative, okay? And so if we wanted to determine whether we were, had the actual, the correct derivative, well, we would just take the derivative with respect to x of big F of x, which would give us the derivative with respect to x of everything else. Okay, so that's x minus x cubed over 3 minus x to the 6th over 2 plus c. Okay, and so what we would end up getting is we would get big F prime of x, which is just equal to little f of x, which is equal to 1 minus 3 over 3 times x squared minus 6 over 2 times x to the 5th plus 0. Okay, the derivative of the constant, some number is just 0. Okay, so at this point, we would just write our function as 1 minus x squared, and then minus 3x to the 5th, which was what we originally started with. And that's the idea, is that we want to, we're just kind of going in a circle, okay? Here's what you had. We're finding the antiderivative, which we just did here. And then if you want to check to make sure that you're right, just take its derivative and see what you get, okay? Let's take a look at number 42. 42 is a little bit interesting. This looks awful, okay? It looks like it's kind of hard to do, but you have to realize that we can simplify this and get it into something that's usable via the power rule. So it looks pretty bad right now. However, let's take a look at this and see what we can do. So what I want to do is I'm going to simplify my function here first before I try and take the antiderivative. And so what I would do is I would separate this out and say that this is really just 4 over t cubed, okay, plus the square root of t all divided by t cubed dt, okay? And I still need to simplify this. Let me do the next step. I'm going to take the integral of 4 over t cubed plus t to the 1/2 power over t cubed, and then dt. Okay, now I'm going to move around my my denominators here and kind of simplify what we've got. So I'm going to have the integral of 4t to the negative 3 power plus t to the 1/2 power minus 3 power. Okay, and what I did there is I'm just trying to simplify this. And if I'm dividing, two functions with the same base, I just subtract their exponents, okay, dt. And so then I get this. Then I get the integral of 4t to the negative 3 plus t to the negative 2.5 power, so that's negative 5/2 power, dt. Now, the reason why I did all this manipulation is because I don't have a rule for this, okay? Here I have a rule. I can use the power rule, all right? So what I would do now is I can now take the antiderivative, and so I've got my 4t. Now I'm going to increase my exponent by 1. So negative 3 plus 1 gives me negative 2. And then I divide by my new exponent, which is negative 2. Okay, same thing over here. Plus t. Now I'm going to add 1 to negative 5/2. I'm going to increase my exponent by 1. So I get t to the, negative 3/2. And then I need to divide by my new exponent, which is negative 3/2 plus c. Okay, so now we need to think about this for a second. We need to go, okay, we can simplify this. I've got 4 over negative 2. That really divides out to just negative 2. T to the negative 2. And then plus, actually I don't need to do plus. I'm going to do minus Okay, now dividing by, this is where it gets tricky. Dividing by a fraction means that I'm multiplying by its reciprocal. So I'm going to multiply it by 2/3 and then t to the -3/2 power and then plus c, okay? And from there, all right, what I would want to do, this is an acceptable form of the antiderivative, but you'd probably want to, go a little step further and say -2 over t squared minus 2 over 3 times t to the +3/2 and then plus c. Okay, so this is really the form that you'd probably want to get. How far you want to simplify these guys really depends on what you're doing. There will be a point in the future when you will want to simplify these, as far as you can, and go from there. So I'm going to go ahead and stop this video, and I will do problems 66 and 70 on the next one. So enjoy. Thanks.